In this example, we are looking to evaluate the limit as x goes to 0 from the left of sine theta over cos squared theta minus 1. The first thing to do in evaluating a limit like this is to go ahead and plug in 0 for theta just to see what happens, to see what kind of situation we're looking at. Maybe it'll just work out and there's no more work to be done, or maybe it's more complicated than we thought. So if we plug in 0 here for theta, well, we get sine 0, which is 0. Well, cos squared of 0, cos of 0 is 1, so that's 1 minus 1, which is 0 over 0. Now, in calculus, this is a red flag, right? This is what we call an indeterminate form, because anything times 0 is 0, but anything divided by 0 is some kind of infinity. So is it 0? Is it infinity? Is it something in between? It's something we can't even talk about. It's essentially almost meaningless. So we need to do some work to get it out of that 0 over 0 form here. Eventually we'll get something called L'Hopital's rule, which will be very useful in dealing with these indeterminate forms. Until we get to that point, let's just see if we can do some simplification to make this a little more manageable. So I'm seeing sines and cosines in there, so I'm thinking maybe there's a trig identity that can help us. That's usually the case with this kind of situation. Remember that we have the old standard trig identity, sine squared plus cos squared equals 1. And maybe you can start to see what's going to happen from here. We can solve this for sine squared x then equals, oh, lo and behold, 1 minus cos squared x. So we plug that in up here. So that gives us a limit as theta goes to 0 from the left of sine theta over, now we have sine squared theta. And there we get our cancellation. So this whole sine theta cancels out with one of these. So that gives us the limit as theta, whoops, not x. We're doing thetas here. X's are always a little simpler, but we'll stick with theta. 0 from the left of 1 over sine theta. And now look, we've dodged that 0 over 0 problem of that indeterminate form. Now we're at least in something that's going to give us 1 over 0. So now we know that we're in some kind of infinity, right? So this is 1 over 0. So it's going to be plus infinity or minus infinity. We just have to figure out which one. So let's look at sine and see if it's positive or negative when we get close to 0. All right, so the graph of sine should be on easy recall. Right, it looks something like this. I hope that is stamped into your mind as something you can bring up pretty quickly. And here we're going towards 0 from the left. As we approach 0 from the left on the x, note that the y's are negative. Sine is down below the x-axis here. So since this sine theta is negative and approaching 0, this must approach negative infinity.